Exercise 1.1 Arithmetic Progression. The first main question. In which of the following situations does the list of numbers involved make an arithmetic progression and why? The taxi fare after each kilometer, when the fare is 15 rupees for the first kilometer and rupees 8 for each additional kilometer. Let us try to convert the English statement into mathematical expression. The fare for the first kilometer is 15, which means A equals 15, and rupees 8 for every additional kilometer. It is D equals 8. The reason the difference for every consecutive kilometers is 8. In general, it can be written as 15, 23, 31. What's the reason to write it 23? If it's 2 kilometers, first kilometer we will be paying 15 rupees. For the second kilometer we will be paying 8 rupees. This is if a person travels first only 1 kilometer, and if a person travels 2 kilometer, if a person travels 3 kilometer, it is not third kilometer, it is totally 3 kilometer. For the first kilometer he will pay 15, for the second kilometer he will pay 8 rupees, for the third kilometer he will be paying another 8 rupees. So the given above situation is in arithmetic progression as the difference is constant between every 2 kilometers, consecutive kilometers. Yes. Coming to the next question, the amount of air present in a cylinder when a vacuum pump removes one-fourth of the air remaining in the cylinder at a time. This question, without any explanation, can be considered as not an arithmetic progression. The reason? Let's consider 100 units of air in a cylinder. When one-fourth of it is removed, 75 units remains. And if you remove one-fourth of 75, the one-fourth of 75 will never be equal to one-fourth of the 100. One-fourth of the 100 is 25. And I don't think so. One-fourth of the 75 is equals to 25, which is less than 25. Therefore, this situation does not form an arithmetic progression. For an example, here I have considered x units of air present in the cylinder. If one-fourth of the air is removed, then 3/4 of the air remains. In the 3/4 of the air, if 1/4 of it is removed, 9/8, 16 of air remains. How did I get 3x/4 here? X units initially, 1/4 of it is being removed. By taking LCM, here I have 4 the LCM, and as we know we're gonna multiply by 4, and here it's 4x minus 1x, which gives me 3x/4 when 1/4 of the present air is removed. The same way, if 1/4 of the remaining air is removed, we have by multiplication we have 3/16. By taking LCM, we multiply this by 4 to make the denominator equal, and obviously we will be multiplying it by 4, so we will have 12 minus 3. 12 minus 3 is nothing but 9, and the denominator remains constant, 16. So here 3x/4 and 9x/16. Let's try if this forms an arithmetic progression. X, 3x/4, 9x/16, 27x/64, and so on. To check if it is an arithmetic progression, let us take the second term and subtract the first term. That is 3x minus x will give us x. Okay, we'll check if a3, that is 9x by 16 minus 3x by 4, if those two are equal. Here by taking LCM we have 3x minus 4x by LCM. 4 is our LCM. Then here taking 16 as the LCM, I multiply up and down by 4. It's gonna be 3 4s are 12x, and 4 into 4 16. The denominator remains constant. So here 3x minus 4x will give us x, that is negative x. Here it's negative 3x, and the denominators of 4 and 16, where both are not equal. What I mean to tell you is d1 is not equal to d2. Therefore, the given progression or given situation does not form an arithmetic progression. Coming to the next question, the cost of digging a well after every meter of digging, when it costs 150 for the first meter and rises by 50 for each subsequent meter. In this case, we can say that the numbers involved are in AP. What's the reason? Because the cost for first meter is 150. So the value of A is 150. And every next meter rises by 50. That is D equals 50. Let us assume a person digs only 1 meter. Then he pays 150 rupees. Let us assume another person digs 2 meters. So then he will have to pay 150 for the first meter and plus additional amount for the second meter is 50 rupees. If a person digs 3 meters, then for the first meter it's 50, that is 150, and for the second meter it's 50, and for the third meter another 50. Obviously you understood. If it's 4 meters, then he will be paying 150 plus 50 plus 50 plus 50. Am I right? I make it 150 here. So here this forms 200 and this is 250, and here it's gonna be 300. Obviously if it's 5 meter we would say 350. So when you cross check the pattern, it's 50 being increased, the D value is constant. Therefore the given situation gives rise to an arithmetic progression. The next question, the amount of money in the account every year when 10,000 is deposited at compound interest at 8% per annum. As the question is related to compound interest, I would say the situation is not in arithmetic progression. What's the reason? The reason is very simple. Here the amount is not constant. What amount? Every year the amount keeps on increasing with uneven increase. What I mean to tell you is, let us assume an example where we have deposited 1000 at 8% per annum. If 1000 is deposited at 8% per annum, for the first year the interest would be 80. For the next year, year month, it's 80 plus 6.4. 80 is the interest on 10,000 and 6.4 is interest on 80. it's mentioned here 1000, 80 is interest on 1000, and 6.4 is interest on 80, where it will add up to 1166.4. The same way, interest for the next month would be 80, 6.4 and 0.512. This 80 is the interest on 1000, this is interest on 80, and this would be interest on 6.4. So it's something like this. When you add up your amounts, it will never form an arithmetic progression. You try it out as an assignment. Write the first four terms of the AP when the first term of A and the common difference D are given as follows. To write an arithmetic progression, these two informations are more than enough: the first term and the common difference. If A equals 10 and D equals 10, first we note down the first term A and the common difference is D is added to the first term. So it's 10 plus 10, 20. Add 10 to 20, you get 30. Add 10 to 30, you're gonna get 40. Add 10 to 40, you're gonna get 50. According to the definition, add the difference to the preceding term. Here 50, A5, that is the fifth term is 50. If I want the sixth term, add the difference to the fifth term to get the next term. So I hope you understood. Yes. Coming to the next question, A equals -2 and D equals 0, but the first term is -2. Add 0 to it, we get -2. Add 0 to it, we get -2. Add 0 to the third term to get your fourth term. Add 0 to your fourth term to get your fifth term. So therefore, they have asked you to write the four terms of the AP. First four terms, A1, A2, A3 and A4. Coming to the next question, A equals 4, D equals -3. So first term is 4, subtract 3, that is -3 from 4 you get 1, and adding -3 or subtracting 3 we get -2, and if you follow it, succeeding numbers are 1, -2, -5 and -8. A equals -1, D equals 1/2. The first term, as we know, it's -1 given, and keep on adding half to your preceding term or the number. -1, add half to it, you get -half. Add half to it, you get 0. Add half to it, you get half, and add half to it, you get 1. So the required terms are -1, -1/2, 0, 1/2 and 1. If A equals -1.25 and D equals -0.25, the first term is -1.25. Add -0.25 to it, we get -1.50. Adding -1.25 to the previous, we get 1.75. Adding 0.25 to 1.75, we have -2. Adding 0.25 to -2, we have -2.25. Yes. The next main question, for the following AP, write the first term and the common difference. The previous question, they had given the first term and common difference, asked us to write the AP. Here it is just reverse. AP is given, we are supposed to find the first term and the common difference. The first term, it's always the initial number, it's 3 for this progression, and the difference, we take second number, subtract the first number, we get -2. Then coming to the next question, -5, -1, 3. As we know, -3 the first term. To get the difference, take the second number, subtract the first one. It's gonna be -1 minus of minus 5, which gives us 4. And here 1, 5, 9, 13. The first number is 1. The difference is 5 minus 1, which is nothing but 4. Coming to the next question, 0.6, 1.7. The initial number is 0.6, which is the first term. The difference 1.7 minus 0.6, which gives us 1.1. The next question, which of the following are APs? So they have asked us to check if the progressions are in arithmetic progression. For this, obviously we're gonna find the difference between the consecutive terms. If a progression is an AP, then the common difference is constant, that is D value is constant. Let us try to find the value of D. Take 4, subtract 2, you get 2. Take 8, subtract the previous number 4, you get 4. What I mean is D1, A2 minus A1, it's 2. D2, take the third term, subtract the second term, that is 4, where we have 4. Since D1 is not equal to D2, we conclude that the given progression is not in arithmetic progression. Yes. Coming to the next question, 2, 5 by 2, 3, 7 by 2. 5 by 2, I can also mention it as 2.5, and 7 by 2 can also be mentioned as 3.5. I guess it is an arithmetic progression. 2, 2.5, add 0.5, we get 3, add 0.5, we get 3.5, where D value is constant, 0.5. D1, that is second term minus the first term. 5 by 2 minus 2. By taking LCM, we have 1 by 2, which is nothing but 0.5 again in the decimal form. D2 is equals to A3, that is 3 minus A2, that is 5 by 2. By LCM again, it's 1 by 2. As I told you, in the decimal form, it is equals to 0.5. Then D1 is equals to D2. Therefore, the given progression is in arithmetic progression. It is in the pattern of arithmetic progression. Coming to the next question, minus 1.2 minus 3.2 minus 5.2. The first term is 1.2, second term is 3.2. So 3.2 minus of minus 1.2. Yeah, minus into minus we get plus, so the difference is minus 2. Coming to find D2, it's term 3 minus term 2, minus 5.2 minus of minus 3.2, where minus into minus is plus, and your answer is minus 2, as greater number is minus 5.2. D1 is equals to D2, therefore the given progression is an arithmetic progression. The next three terms are, if it is an arithmetic progression, they have asked us to write the next three terms. So keep consecutively or successively keep adding minus 2 to the previous number. Your minus 7, add minus to it, we get minus 9, and add minus to it, we get minus 11. Add minus to it, we get minus 13, then 0.2, it's all as it is, and it just goes on. Coming to the next question, minus 10, minus 6, minus 2, and 2, so on. The initial number is minus 10, and the next number is minus 6. We are supposed to subtract minus 6, minus of minus 10. The minus into minus is plus, the difference is 4. And here take minus 2, subtract the previous term, minus 6, where we have minus into minus is plus. Yes, D1 is equals to D2, therefore the given progression is an arithmetic progression. Therefore the next three numbers are 6, 10, 14. How come? Here 2, add the difference 4 to 2, we get 6. Add 4 to that 6, we get 10. Yes. 3 plus root 2, 3 plus 2 root 2. The first term is 3. To find the difference, t2, that is a2 minus a1. a2 is 3 plus root 2 minus 3. So 3 and 3 gets cancelled. The left out is root 2. To find d2, it's third term minus the second term. Third term is 3 plus 2 root 2 minus 3 plus root 2. Here, when you open the bracket, it's minus 3, plus into minus, it's minus root 2. 3 minus 3, we get 0. 2 root 2 minus root 2. How did we get minus over here? It's like multiplying minus into plus, we get minus root 2. So out of 2 root 2, if 1 root 2 is subtracted, the remainder is root 2. So it's root 2. The d1 is equals to d2. Therefore, it is an arithmetic progression. So the next 3 terms will follow as 3 plus 3 root 2. Here it's 1 root 2. Here it's 2 root 2. The next number obviously will be of 3 root 2. And the next is 4 root 2. The next is 5 root 2. The next question, 0 minus 4 minus 8 minus 12. Obviously the difference is minus 4, I believe. Minus 4 minus 0, it remains minus 4. Minus 8 minus 4. Minus 8 of minus 8 minus of minus 4 gives you minus 4 again. Here minus 4 and here minus 4. The answer is constant. The value of d is constant. Therefore, it is an arithmetic progression. Then the next 3 terms of the same progression are minus 16, minus 20, and minus 24. The next question is minus 1 by 2, minus 1 by 2, minus 1 by 2. The difference is 0. Therefore, it is an arithmetic progression. a2 minus a1, that is minus 1 by 2 minus of minus 1 by 2 is 0, where d2 remains 0. Therefore, the given progression is in arithmetic progression. The next question. The next question, 1, 3, 9, 27. Obviously, this is not an arithmetic progression, as the first term is 1, the second term is 3. The difference between 1 and 3 is 2, but the difference between the next 2 terms are, it is 6, where d1 is not equal to d2. It's explained here. a2 minus a1, 3 minus 1 is equals to 2. a3 minus a2, which is equal to 6, where d1 is not equal to d2. Therefore, it is not an arithmetic progression. Coming to the next question, a, 2a, 3a, 4a. Obviously, it is an arithmetic progression, where a, 2a, so the difference is 1a. 2a, 3a, the difference is 1a. 3a, 4a, the difference is 1a. And we go like this. d1 is equals to a2 minus a1, where 2a minus a is equals to a, and 2a minus a is equals to a. d1 is equals to d2. Therefore, it is an arithmetic progression. Coming to the next question, we have the next 3 terms. It's 5a, 6a, 7a. Yes, the next term would be 8a. Yeah, coming to the next question, it is a square, a cube, a power 4. Obviously, it is not an arithmetic progression, because to get the succeeding number, here they have multiplied the previous number. A into a is a square. Multiply a square, you get a cube. Multiply a cube by a, you get a 4. Here, a square minus a cannot be subtracted, so it remains the same. Coming to d2, a cube minus a square, it's again cannot be subtracted, as both are unlike terms. It remains the same. d1 is not equal to d2. Therefore, the given progression is not an arithmetic progression. Okay, students, if there is any doubt in the concept, please leave your comments so that I can try to solve your doubts. Thank you. The next question is root 2, root 8, root 18, root 32 here. Since it is in third form, let me try to convert into simplest form. It's in the pure third form to the simplest, or we call it as mixed form. Here 8 can be written as 4 into 2, and 18 is written as 9 into 2, 32 is written as 16 into 2. It's just because 16 is a perfect square and 2 a non-perfect square. Here a perfect square and a non-perfect square, a perfect square and a non-perfect square. Square root of 4, obviously it's 2. Square root of 9, it's 3. Square root of 16, it's 4. So now you can see there is a pattern: root 2, 2 root 2, 3 root 2, 4 root 2. Obviously the next number will be 5 root 2. So therefore it is an arithmetic progression because it is increased by root 2. Second term 2 root 2 minus the first term root 2 gives us 2 root 2. The same way d2 a3, that is 3 root 2 minus 2 root 2. The answer is root 2, where the difference is constant, therefore it is in arithmetic progression. Yes, the given progression is in an AP, arithmetic progression. So the next terms would be 5 root 2, 6 root 2, 7 root 2. The reasons are, okay, here it is in the simplified, root 32. So it's 16 into 2. So the next number would be 25 into 2. 25 into 2 is nothing but 50, and it's 72, and the other one is root 98. I hope it's clear. Then coming to the next question, it's root 3, root 6, root 9, root 12. Even though the numbers 3, 6, 9, 12 are in arithmetic progression, but the whole given progression, that is root 3, root 6, root 9, root 12, are not in arithmetic progression, where we cannot simplify it further just as we did in the previous question. Root 6 minus root 3 cannot be subtracted, as we call it as unlike surds. Yes, coming to the next question, next part, a3 minus a2, root 9 minus root 6, which cannot be simplified again because it is in simplified form. Yes, and d1 is not equal to d2, therefore the given progression is not in arithmetic progression. Coming to the next question, it's 1 square, 2 square, 3 square, and so on, which is not in arithmetic progression again. The reason: 1 square is 1, 2 square is 4, so 4 minus 1 is 3. The third term is 3 square, which is 9 minus 4, and it's equal to 5, where the difference are not constant, therefore it is not in arithmetic progression. Yes, let's go ahead with the next question. It's 1 square, 5 square, 7 square. Is this not in arithmetic progression? You're right, it is in arithmetic progression. What's the reason? 1 square can be written as 1, 5 square, it is 25, so 25 minus 21 is 24. At the same time, 7 square is 49, 5 square, as you know, 25, 49 minus 25 is 24. The difference is constant, therefore it is an arithmetic progression, and the next 3 terms of the progression are